Hello, I'm Mark Kotancheck. I'm the Chief Technology Officer for Evolved Analytics. Today I will be talking about GUI development from a practitioner perspective. What we have in a lot of the data model, in a lot of the Wolfram documentation is operating at the dictionary level rather than sort of a holistic system building level. So what I want to talk about is that holistic system building. So the notebook here, the slide deck is on the server, so could you turn the volume down just a little? So it's out there. We're going to blip through a lot of stuff in a short amount of time. So I just wanted to put together as a slide deck for reference material. So what's the advantage of a GUI versus a notebook? A notebook is a wonderful thing. That's better. A notebook's a wonderful thing, but it's got this linear view. It's got an audit trail. The problem is the sequence matters, and you've got this sort of long distance interaction. So that if dropping into a long analysis, if I forget to evaluate an earlier cell, I'm sort of hosed. But the plus of notebook interfaces is there's no limits. Whereas in a GUI, and so what we have here is an analysis notebook using data modeler versus the data modeler GUI. So now you've got this sort of nonlinear interaction, be able to flow, jump around, say, okay, these variables in this case look interesting. Let's pop back, look at their properties, and be able to flip around. We also hide the complexity and the design, but the design limits the functionality. That can be good. It gets you ease of use, but it's got some downsides. So what we're going to do real quick is talk about some of the motivations, a little bit about manipulate, talk about how to lay out the GUI within Mathematica, development environments, running through some of the nuts and bolts of dynamic, and then finish up with some of the system building issues around deployment and IP protection. GUI is wonderful. You got this sort of natural nonlinear workflow. That's a big plus of it. We've got a lot of people in the world that can't handle holding down the shift key while they hit enter. Hide that complexity of that. Don't have to know naming conventions of Mathematica and all that sort of stuff. Big wins for GUIs for Joe Schmo user. Credentials for myself and Ariel. Data Modeler is one of the largest GUIs built 100% pure Mathematica. But I've also built an image analyzers as well as knitting pattern started off as my wife's birthday present. Ariel has, we collaborated on the data modeler GUI. He's also got a number of products as well as his own consulting work. One thing here, so just this is a response contour plot explorer. One of the things about the GUI, as we start to do it, note the use of field hints. That's something as you build it to guide the behavior of the users. So what's great about Manipulate is it's so fast to do quick and dirty. It's got intelligent defaults. And you can get something that's reasonably decent in a fairly quick time. This was for a client that was a professional baseball team, just sort of looking at pitch state transitions of various counts, what's going to happen, just statistic. There's close to 1 million pitches per year in Major League Baseball. So a lot of data there. What's wrong with Manipulate is that it just doesn't really scale well. If you get something more sophisticated. I put this is the initial instantiation of the knitting software for my wife. 50, 60 lines of Mathematica code, and you got something sort of neat to play around with slipping stitches and creating Argyle patterns and all, defining colors. Pretty neat. The problem is when you start to go to the next level, then it sort of runs out of steam. But manipulate's handy just as a general thing. We got into a consulting project and doing image analysis of microscopy, 3D stacks of images. And mathematics is fantastic, okay? You've got all these capabilities, and you've got all these options, and you've got options on the options. And so now you know everything's in there. How do I design a flow? So I wrote this little explorer to let me sort of sequence the operations and to get the behavior I wanted out of against the data sets. And let's see. So anyhow, a lot of capabilities buried in there in a fairly succinct exercise. When you're doing a GUI, tab view and opener view is really your friend. You want to sort of lay out the structure first, and then start populating it iteratively with capabilities. But so these are the tools and the functionalities you care about as you work. The other one thing that's important is to care about your. Not everybody is running on a 27-inch iMac with oodles of screen real estate. You got to respect the 11-inch MacBook Air and be able to let people handle that sort of variety. Very important once you get to a certain level of complexity is shifting over to Workbench. You've got a lot, GUI code, unlike normal Mathematica code, is pretty verbose. So what you want to do, you just sort of need the Workbench environment in order to manage that code, to do the replacements. Thing that's very important is in Workbench, you run the code under the control of Mathematica underneath Workbench, because those dynamics can run amok so easily. And when they run amok, then you have to kill the kernel, and then you lose all your code edits if you're operating in a Mathematica notebook. Here, at least, you're separated, and you get a chance to get back control and degrade gracefully and recover from that. Just to give you an idea of where we're at scale-wise, Data Modeler's 30,000 lines of code. The GUI is another 15,000 lines. There's a lot of functionality there, but it's just natural. It's still more verbose. I'd also go for coding conventions and lesson learned the hard way for my image analysis stuff. Document as you go, because use the Workbench to do the documentation and make sure you know what your functions really are doing. Then once you have the basic structure of your interface, then you start to have to populate it with controls and displays. There's just lots of things in there. The sliders, the switches, very rich. Color setter is wonderful because we got into trying to do some stuff as an iOS app, and it turns out you don't have a color setter in iOS, which is sort of an amazing thing. But you really want to care about the layout and the controls and the interface, and the aesthetics are very important in my view. So this is the a view within Data Modeler. Looking at some models that have been developed. There's a lot actually buried in this thing from a design aesthetics perspective. All right, so here the input set had 240 variables that we're trying to sort through. So just as a thing, we've covered that. Okay, so first thing, palette. Palette's a nice thing, but they don't have to be ugly. It seems to be the convention in Mathematica that palettes are ugly. But using some colors, highlighting, because the user really basically largely is going to care about launching the GUI or else launching an analysis notebook. There's a workflow to the analysis. So we put the tabs on the top, so you can click through and bounce back and forth, but there's a natural support for that workflow and the cycle. And also the ability to bounce back and forth. I mean, you get into a long mathematical notebook. Now I've got some results. I'm going to go back and look at the data, which was way back in the beginning. I got to get there. So being able to use these tabs to bounce is important. Important thing if you're building a GUI, logical file names. Help the user out. Give them file names. Give them timestamps for the files so that they don't overwrite things. In our case, we have variable sets. So I start off with 240 variables. I get it down to a lower amount that I want to drill in. Let me make it easy to get to that lower amount. Again, the use of the openers. Here we've got various controls and explorers to look at our developed models. But I can't show them all on screen at the same time. They don't need to all be on screen on the same time. I just have to make it reasonably efficient to get to those views. Same deal, the Explorer controls. Here we're looking at a variable presence chart for the variables, which ones have emerged to the fore. I can, I've got controls. Each of the Explorer functions have these controls, but they're hidden by default, but easily accessible. You also have the ability, one of the great things about a notebook environment is it's got this natural audit trail. So in this case, you've got to allow the user to create that audit, the equivalent of that audit trail, and preserve results and do the analyses. Tooltips are important. You have to be a little bit careful about tooltips in Mathematica because a lot of them will bring the front end to its knees. But it reduces clutter, visual clutter, but still provides insight when available. And then I guess finally the things that can be dynamic should be dynamic. So here the image size and aspect ratio are dynamic, so the user can just slide that thing and the plot scale quickly, so you don't have to recreate the plots and the analysis to generate that view. So a lot of details went in there. And this is just a single slide with what I just talked about. Now this was the image analyzer project. When you're dealing with stacks of microscopy images, just even loading in the data takes time, much less analyzing and extracting information. So a life science important out of this exercise. And eventually the whole point of this was to create a data set that we could send it to data modeler. So each stack would result in 1,200 attributes that we then sorted through to say which ones were really affecting the characteristics of interest. Learned a lot in this process because I did the mistakes for you that I'm talking about here as best practices. This is what the knitting software has morphed into. Again, a lot of stuff, but having a reset button is a good thing to have in any of these interfaces to let the user get back to a known state. This is a little bit fun because entering stuff in some actions areas, you want to disable other controls depending upon the state. So you have keeping track of those sorts of things. And again, tooltips and field hints are important from a user perspective. Now you get into the actual dynamic code. And the wonderful thing about dynamic is it improves your vocabulary because you learn how to swear and sling things together in new and novel ways. What you really have to do is be methodical, partition the functionality, really understand there's a second argument to dynamic. That's so important to get the side effects that you're really looking for. So you've got to do that. The other thing here is, do not use track symbols on arrays and images and large things. If you can get it down to a counter or something small to trigger, that's going to make for a much more reliable and responsive interface. Dynamic module by default embeds its information, the stuff that's supplied to it, in the dynamic module. So, this is great, but here I've got, I can have thousands of variables that are in my original data set. This is looking at the response behavior of a model. Well, only 3 of the variables are in my model because I've done this analysis. So I've got functions wrapping that are not dynamic outside this thing, which presents the dynamic module with only the minimal information required, because I want to keep that footprint small and make it responsive. Okay, so and because that stuff embeds. Layering, so if you write sequences of dynamic modules and then layer them, you get duplicate copies of stuff unless you're careful. Well, I should also say that control active is an important thing here, because these response envelopes of uncertainty change as I move my points around in parameter space. So we use control active to reduce what's displayed while the control is being used, and then you show the full view once it's released. And that leads us very sort of naturally into slow computations. You really have to be explicit about that, have to understand the differences between synchronous updating states, and also provide feedback, because if you have something that takes 30 seconds to evaluate, people can't look at a blank screen for 30 seconds without clicking on stuff and adding more things to the queue and breaking stuff. This little detail on life-side panels. Turns out that within the CDF, you can't update a dialog box. So the approach I used is to actually write multiple windows and put one window on top of the next one and delete the one below. Little bit of a sin of omission in input fields, in that if you restrict the input field to be a number, and you enter in George as the entry into the input field, well, it doesn't display George, but the dynamic variable gets reset to George, which you need to use the second argument of dynamic in order to trap these sorts of situations. Lots of tooltips will bring things to its knees, the front end to its knees. Keep it under 1,000. If you're, don't run amok there. And then the other issue is that Workbench is only sort of marginally maintained. There's hints of a refresh, but you really need to use it, but we need more support in that. And then, of course, I'm looking forward to a CDF implementation for the iPad. When you get to the notebook creation phase, the big one here is you want to put savable to false so that people aren't prompted to save the notebooks. You can still do that. In terms of deployment of systems, when you build these GUIs, if people have Mathematica, that's cool. You can just use the notebooks directly. CDF Player Pro is about $200 a pop to hand off a license to them. Alternately, you can have Enterprise Mathematica, which is 10% of revenue with a minimum of $12,000. That has the advantage that I can create notebooks and just throw them out, and they can. And the advantage of the CDF Player Pro and the Enterprise is that the notebooks that you create, or the GUIs that you can create, can read and write data. So they're not, they're more dynamic. And I haven't looked at anything around the cloud stuff. Best practices, basically good design, good development. Don't write spaghetti code. You guys can read this, sort of offline. I don't think that's, develop functions that you reuse as part of your notebook. For example, all those openers, every opener in Data Modeler, we're doing these explorers. Well, that has a common frame. So there's a function there, and we've separated the data from the functionality, so it's more maintainable, okay? And don't make it ugly. So speaking more of best practices, I'll do my pitch for Ariel and his software. Again, I mean, he understands dynamic far better than I do, as well as interface design. One issue is for intellectual property. You don't have what you store as a CDF by default is just plain text. So I mean, it's there. If you don't want that to be there, use in code and do some other stuff to get her locked down. You can lock down to a machine ID if that's appropriate. And then my advice would be script the encoding. So this is the data modeler GUI in code that's displayed to the world. So conclusion, I love GUIs, love them. I hate GUI development, but if you're disciplined, you can get to success, and it's not too onerous. And there's contact information for me as well as Ariel, and that wraps me up. So we have 2 minutes for questions, if there is.